And we're live. Okay. Hello, everyone. My name is Joe Barnard. We're going without the glasses today. We're keeping it funky and fresh. If you can see me and hear me, toss a little 5x5 in the chat. And we will get this show on the road. We're doing another one of these 2-week, 1-year delayed Patreon updates. And yeah, that's what we got going on here. Thank you guys for joining. We got a couple of viewers. We're cooking here, I think. We toss a little notification out to Discord, and then we'll just get right into it. So the way these things work, if you're new here, what we're going to do is we're going to look at a Patreon update that I posted about a year ago, a little more than a year ago, and review it, just like see what I was doing 1 year delayed. And then we'll talk a little bit maybe about the update or maybe about what I'm doing right now. And it's just like a good opportunity to hang out. So thanks everyone for joining. Let us get into it. So this update was posted on, looks like 1 year ago. Let's see. Firing on March 31st. I posted this on March 19th. And I believe in this, we're just talking about igniters. So there's some spicy stuff in here. I haven't seen it. So like, we'll see what's in here. I don't think it's that crazy. But yeah, I will keep an eye on the chat. If you have questions, I will answer them after we're done. So we got about 17 minutes to go here. All right, here we go. It doesn't seem like this is actually coming in, and I think it's because we haven't selected this. Okay. 2-week update, and before we get started, I just want to say we are firing this motor on March 31st at the Friends of Amateur Rocketry test site. If you are in the area, you are more than welcome to come join. It will be a little bit later in the day, possibly like 5 to 6 p.m., and it should be great. And if you can't make it, do not even worry, even a little tiny bit, because we are also going to be live streaming it. Now, let's jump into this episode. When we left off last week, I was talking about making igniters, and so we'll jump into that here. I will tell you that I'm using a compound here called MTV, or magnesium, Teflon, and Viton. There are some other common compounds as well, like boron and potassium nitrate, and a couple other. I think it's actually called Viton, but it doesn't matter. MTV is a little bit sensitive to static, and I think in the future I'd like to switch to the boron and potassium nitrate blend, but for now, this is good enough. It is very good at igniting motors, and in the right quantities can achieve something called like an instant on, where basically your motor goes from 0 thrust to full burning in a few milliseconds. So that's what we're hoping to achieve here, and here is how I am testing those little ignition things. So the whole idea with this HEI bolt, or head-end ignition bolt, is that at the very end of it we have this wire mesh. It's kind of like chicken wire but a little bit thicker. It's made out of regular old aluminum, and I think they just stamp it in a big sheet. What I've been doing is cutting out small sections and then rolling them around a brass tube. The brass tube is about a 1/2 inch in diameter, and you usually roll it so you get like 1 or 2 wraps of it. The reason we use aluminum for this is because we know it's going to burn away, and it's going to happen pretty quickly, and we do want that. So a mass like this at the very top of the motor, if it doesn't like burn pretty good before it gets to the nozzle, it will clog the nozzle, or could potentially damage the graphite. And so the goal is that, like, pausing right here, I know a lot of people at this point who have used stainless steel mesh without a problem too. I'm not saying that like you will hurt your rocket if you use stainless steel or aluminum, but the aluminum seems more likely to combust than the stainless steel. That's all. Like, this thing sticks around for as long as it can when it gets epoxied to the bolt, but you know, as the motor is burning, it just evaporates. The other thing is that the aluminum kind of just like vaporizes when the MTV ignites. It is a really scary and angry compound, and so messing with it always happens in the backyard or outside as much as I can, and always with lots of personal protection. One more thing. We're going to try not to pause too much. I can't emphasize enough how much you do not want to be playing with this. I get a lot of comments from kids who are younger, maybe say 14, 12, 16, whatever. Don't mess with this. I really mean that. Do not mess with this stuff. I can't emphasize enough. It will really, really hurt you in ways that you can't understand until it is much too late. These are really energetic compounds, and it's like fun and cool to do rockets, and it's not fun and cool to like put yourself in the hospital with permanent damage to your body. So I can't emphasize enough, this stuff is sensitive in all sorts of ways that you might not understand coming out of it. We're just putting a big safety thing in here. And then the other thing is Yeah, no, we're just putting a big safety thing in here. Do not mess with this stuff. Theme in testing this was figuring out where to place the igniter and how to actually cast this stuff. So the first test of this thing that I'm doing had the igniter embedded sort of at the bottom of the material, and then I basically poured the liquid MTV or the uncured MTV into this like section. Think of it like pouring a pellet of MTV into this, and then the chicken wire or the mesh is sort of like holding it in mechanically. The results here don't look terrible, but they also aren't really what I'm looking for, and I found that casting this was a lot harder than I anticipated. Next up, I used 4 of these mesh rounds and tried several different placements of igniters. The first igniter was placed in the hollow center of the MTV grain, and I figured that the material or the pyrogen would be sensitive enough to actually light, and boy was I proven wrong. It turned out the igniter fired and the MTV did nothing. This told pause, really quick pause, if it was just magnesium and Teflon, it would have lit. Again, don't mess with this stuff. The Viton changes the properties of it. I don't mean to be like big safety boy, but it's the same exact amount of danger as making your own propellant. And you do not understand the danger of working with these things if you are not working with a mentor. I worked with a bunch of people on this to determine like how best to safely make it. Told me that igniter placement was probably a little bit more important than I was giving it credit for. So for the next test, I took a black powder pellet and put it on top of the igniter inside the MTV grain, and that amount of energy worked a lot better. I mentioned earlier that the aluminum sort of gets vaporized by the MTV, and it does look like it's still intact here, right? But it turns out, no, it is not. It is like all ash at this point. One thing that I noticed is that a lot of flame was shooting out the top of the igniter, which I guess is the bottom or faces the nozzle. I wanted to minimize this just a little bit. I wanted a little bit more radial fire than just downward fire. And I put a little slug of hot glue at the top of the MTV section here. That wasn't a very good idea. I mean, all these tests are conducted behind a bunch of walls and like, you know, should be pretty safe, but that did not work well. It was a little bit more explosive than I was comfortable with, and like at a certain point you have to start worrying about cracking the propellant grain if you pressurize too fast or too aggressively. And so this approach also did not work. For the fourth one of these tests, I embedded the igniter into the side of the MTV. So basically there are all these little holes in the aluminum mesh, and the ignition head, the igniter head, can fit inside of one of those holes. So when the igniter fires, we get lots of good like exposed surface that is directly to the side of it, which means we're probably going to get ignition every time in the way that we wouldn't if the igniter was just free floating in the center of this like MTV grain. This seemed to work really well, but I wasn't stoked about the idea of embedding the igniter into the MTV so that it was basically always primed and ready to go. So I tried one more approach where I put a bunch of blue tape around the MTV grain to tape the igniter in there, and then I added a little bit of black powder around there to sort of like give it some encouragement. This worked okay. It wasn't that great, and at this point, like, the results with all of these are pretty inconsistent, and I'm learning that I think embedding the igniter into the MTV is probably the way to go. Is it really a BPS video if I don't manage to use both hot glue and blue tape, which we're 5 minutes in and I've used both? Also, one little bonus clip here, I took an igniter head and just coated it in the excess MTV that was mixed up with the batch that I made for those 4 igniters, and then fired it here. This is the kind of igniter you would use for a slightly smaller high-power motor, and it could light some pretty big ones, but just not as reliably. Okay, now we are on to the next batch. I made 4 more igniters here, and I cast the igniter into each one of them, which means that as I was making these, I embedded the igniter into the MTV. Now, of course, just so we're clear, I'm doing this with twisted leads. I'm doing this after we've, continuity checked all of the igniters so that we never have to do that until it's actually time to fire. The results with these igniters were far more consistent in terms of the ignition come-up time, in terms of the ignition itself, in terms of the obliteration of the aluminum. These results were a lot better than the first 4 that I made. I found that with this approach, we had good ignition on both the inside and the outside of the MTV grain at about the same time. Ultimately, for the space shot stuff, I believe this is better for the reason that when we ignite the second stage motor, we want that to be pretty deterministic. We want to be able to tell the motor, hey, turn on right now, and have it respond to that command. I think for a lot of high power launches, you can see, especially with like Lumineer and some of Sendit's flights, there's sometimes of a delay of like 5, maybe 10 seconds where the motor is just sort of smoking and like building up to thrust. And those 10 seconds on a space shot, like, for a well-designed rocket, won't make a huge difference, but they will make a difference. And so having instant on ignition or near instant on helps us a lot here, which is why I'm focusing so much on the ignition stuff. Also, for what it's worth, I shot all of this high-speed footage with a camera that is not that fancy. This is shot with the Sony RX100 Mark IV. I bought this thing a long time ago, and if you're looking for a camera that can do like 1,000 frames per second, even if the quality isn't great, it's a really good option. If you know where to look, you can get them for pretty cheap, and the ability to shoot 1,000 frames per second, again, like even if the quality isn't good, is such an awesome asset to have. I mean, being able to see the ignition come up of all of these igniters with basically a point and shoot camera is really valuable. Anyway, moving on, I'm pretty happy with this igniter design. There are some things that can still totally be improved. Igniters are a really tricky subject, and it depends on like where your level of safety is and what type of transient you want when you ignite the motor. So I'm totally open to feedback, but I probably will be using these for the first few motors, or at least the first one, and then might change it down the road a little bit. But that is the igniter situation. Let's move on to the test stand now. So I'm making this test stand out of 1515 aluminum extruded rail, or T-slot basically, which means that it is 1.5 inches in every dimension. It's like a little square cross section, and it's kind of like engineer Legos. As far as building a test stand goes, this is definitely like on the more expensive side, I'll be honest, but I do love the look of this aluminum extrusion, and you kind of can't beat aesthetics for someone who's doing a YouTube channel. All this stuff goes together pretty easy, and the basic design is that we have a square-ish shape on the bottom and a square-ish shape on the top. In between, me when I don't understand what a rectangle is. We have these 4-foot long segments, and when we move on to a longer motor, like the 8-foot motor that we're going to use for the actual space shot, we can take these segments and replace them with something longer, and the design for this thing will basically scale up with that. I'm putting considerable effort and money into this test stand because I want it to last for a few years. I want it to fire a bunch of different motors. And so like something quick and dirty is fine, but what I want to do is like build this once and then never have to do maintenance on it. So for what it's worth, still works great. I have not changed the software on that test stand since last summer. And like I turn it on, I hit the button, and it does all the things it needs to do and logs the stuff. Even these little pieces of RTV like have held up great. I got a lot of flack for that on the main channel for like such an inelegant solution, but like, dude, if it works, it works. I will say, and I think I talk about this on the main channel, dude, they're like cutting down a forest behind my house. I don't know what's happening. I will say, if a motor ever burns through in the wrong spot, it will disassemble this test stand. Like, and you can also eat steel. Like, you can eat steel with hot motor gas. You can eat a lot of metals, but aluminum is going to get eaten really easily. So I don't like, if I were doing this and didn't want to make a pretty stand for a YouTube channel, I would just do like a steel beam with like a load cell and a pressure transducer on the other side, or with a remote thing. I don't think this is the right way to build a test stand, but it is the way that I did it. So we're firing this motor vertically, which means the exhaust is going to go up in the air and the thrust goes into the ground. But in order to secure it vertically, we want a couple of points of attachment. So the way I'm doing this up top is a little bit janky. We might change it down the road. But basically, I took these 1/4-20 threaded rods. I coated them in RTV with a coupling nut on the top to basically give them like a squishy, soft top that won't mar into the aluminum case. Then I drilled holes at the halfway point of all of the 1-foot segments that are at the top of the test stand. I then used a drill to tap these holes so that the 1/4-20 threaded rods could actually thread into this horizontally. I did this on all 4 sides, and then I cut the threaded rods to a more appropriate length so they weren't sticking out like crazy at the top. The nice thing about this approach is that it allows me to test a couple of different diameters of motor, all the way down to, I mean, theoretically like 1-inch diameter, which is probably not a scale that, you know, needs to be fired on this test stand, but it allows for expansion or de-expansion. I also very valuable because I have fired 2-inch motors, I have fired 4-inch motors, I have fired 6-inch motors, and later this year I will fire an 8-inch motor in the stand. And the stand does not have to change to accommodate those things. At the end of the threaded rods in RTV2 as sort of a way to protect against scratches and stuff like that. Feels like it's probably worth doing. One thing that I didn't mention is that these other like bolts or rods that are sticking out of the top here, this is how we're going to tie this thing into the ground. Now, we're firing the motor into the ground, but obviously you have to keep the test stand vertical as well. So I'm using some steel wires basically that are going to tie it into the ground. I was going to use nylon straps, and then my buddy Charlie was like, hey, here's a question. What happens if a chunk of propellant gets on the nylon? And I was like, that is a really good question. I'm going to go buy some steel rope about it. Okay, and now it is time for Manufacture Palooza. We are going to start off with something that is going to allow us to hydro test this motor. Hey, Joe, what is a hydro test? Oh my gosh, what a great question. Basically, what we want to do is we're going to fill... Why anyone watches this channel is beyond me. Also, cheers. We're doing a little Dr. P today. Fill up this motor with a bunch of water, which is a lot less explosive, or like has a less explosive potential than high pressure air. And then we're going to pressurize the whole thing to above its expected burn pressure. This means we're going to see if the O-rings in the HEI bolt, the O-rings in the forward closure, the O-rings in the nozzle, if those are all going to seal. And, you know, especially if they don't seal, that's really good for us to find out before we fire it. Anyway, one of the parts that I have to make here is basically a plug for the throat of the nozzle. I want to use the actual nozzle during this hydro test. And so this piece of aluminum is going to get turned into a plug that goes into the throat of the nozzle. It took a little while, but I spent a couple of hours turning this thing down on the little mini lathe, which every time I use it breaks just a little bit more. And then I turned the taper on this section, and this is the exact angle of the converging section of the nozzle. And so the goal here is, the plan at least, is to put an O-ring on this section, hold it up against the nozzle as we pressurize to maybe 50 psi where things are fairly safe, and then I can leave the site, can move away to somewhere safe and pressurize to like 1,000. I also, mostly for aesthetics, polished the crap out of this thing, and I'm really proud of it. I'm going to start polishing my aluminum parts more. I think this thing looks really nice. Now, it has a hole down through the center because this is where we're going to actually fill the tank with pressure, and so I tapped this with 1/4 inch NPT, which is what a lot of my fittings are, and then I added a quick disconnect fitting here so that we could actually connect to it once it's installed. Next up, I started testing different mixes of insulator material into epoxy to test basically its resistance to heat. You'll see where this comes in a little bit later, but basically we're trying to create a sort of liner material to protect the HEI bolt, and specifically to protect the RTV inside of the HEI bolt. I'm using an insulating additive here called Thermacells.
Love Thermacells.
Usually it's used for paint, but they're these really, really, really tiny microspheres of basically ceramic. First of all, I just want to make sure we're all clear. This is a hilarious label on this bag of Thermacells. Quote unquote, NASA spin-off technology. And half of it is in Comic Sans. Anyway, that's all. The two mixtures that I tried here were 25% and 40% Thermacells. After this had cured, I took a torch to both of them to see how much they would ablate over the course of several seconds, and I found that the 25% actually fared a little bit better. After a certain point, you get more Thermacells than you do epoxy, and so the bonds that actually keep the material together start to fail a little bit faster. So it seems like the ideal additive amount here is probably 25, maybe 30%. So also ideal additive is Kevlar, but that's not a thing we have talked about on the public channel yet, but will. The way we're doing the HEI bolt here is that I'm threading these igniter heads through the center of this bolt that I made in the last episode. And then I'm also filling this thing to the brim with RTV, hoping that, it's a little bit tough to make sure that it's 100% filled, but with enough length and, with enough RTV, it should seal ? Basically, just added a bunch of RTV in here and then left a gap at the top because we're going to fill that gap with the epoxy and insulating additive. Next up, it's time to make a little tiny thing on the lathe. I'll keep this super quick because it's kind of a boring part. Basically, when I ordered the load cell for this test stand, I accidentally ordered one that went up to 20 tons, which was way more than we would ever need for the level of motors that I was going to fire. And so instead of returning it, I saw it as an opportunity to demonstrate the differences between different types of load cells and ADC resolution. And so I took this load cell and then I took the appropriate sized load cell and I created a little bit of an adapter between the two. Next up, I needed to make a base for the test stand. This part was definitely overkill, but it looked really cool, so it was totally worth it to make it look nice. Basically, we need an interface between this massive load cell and the base of the stand in a way that distributes the load a little bit better.
Shout out blue tape.
So basically, using the most sketchy work holding technique, which is cyanoacrylate and blue tape, I milled this thing out on the Tormach. This guy bolts right into the base of the test stand, and again, it's pretty overkill for what we needed to do, but it looks nice. Then, after the RTV had cured in the HEI bolt, I added a big slug of this insulating additive epoxy to hold the chicken wire in place or hold the aluminum mesh in place. Now, I didn't add any RTV on this thing. The goal wasn't to make a real igniter. The goal was to make a sample igniter that we could use for a hydrostatic test. And like then if it passes, we can make a real igniter. But there's a non-zero chance that like something in this design doesn't work, and so we have to revise it. So we make a fake igniter, and then we'll make a real one. All right, and then next up, we needed to make a joint between the rocket motor and the top load cell. So this is another big old chunk of aluminum, and by this point, I had acquired toe clamps, which are way better than the blue tape method. This part got machined in 2 operations, and I did kind of a crappy job aligning the 2 when I flipped it, but like, I don't really care. The margin of safety here is very high, and at this point, like, I want to not be making parts. I want to fire rocket motors and do rocket things. I milled out like 90% of this on the Tormach, and then I turned the rest on the lathe so that we had a little bit of a lip that we could attach the rocket motor to. And that is truly all the parts that need to be made here. We are done with making metal parts. We're done with like big acquisitions and big tech development and stuff like that. At this point, I need to hydrostatic the test stand, or I need to hydrostatic the motor on the test stand. And then once that's done, I need to finish the ground software, which is just like a slightly modified version of the Ava flight software. And after that, it is time to fire. So once again, the firing is going to happen on March 31st. So that's just under 2 weeks from when I'm posting this. And once again, you are welcome to come to the Friends of Amateur Rocketry test site to see this thing in person if you want. I will try to bring some BPS stickers and can hand some out as well. But I will tell you that you should stay super posted in the Discord, just in case anything changes. There's a total chance that the hydrostatic test fails. There's a total chance that something else goes wrong, or who knows what happens. Schedules do schedule things sometimes. So stay posted in the Discord and on the Patreon. I will keep you all in the loop. And I super appreciate your support as always. This is a wild project, and there's a lot of tech development that has to happen behind the scenes. So Patreon is a thing that makes this so much easier and much lower stress as I like figure things out and can show you in real time. Anyway, thank you again for watching. Thank you for your time and for your support of this project. My name is Joe Barnard. May your skies be blue. May your winds be low, and I will see you at FAR in 2 weeks. Woo! All right. See ya. Bye. Chill, dude. Oh, my gosh. All right. What's up, pals? How are we doing? I know that I don't think you guys can hear it, but, like, genuinely, they are ripping apart the Amazon rainforest outside of my door. Literally, like, 2 feet from my door is, like, industrial level deforestation. I don't know what's happening. I can't actually see it, but just like every 10 seconds or so, they go and they're just like eating through trees. I don't understand what's happening. Anyway, what's poppin'? Now we can just like hang out for a little bit. I got my Dr. Pepper. I got my seltzer water here, and I'm happy to answer questions, to chat, to tell you what we're currently working on. I've got a script that is almost finished that I'm going to film tomorrow, and then will probably be published next week about guidance and control. And yeah, that's what's popping. Also, thank you everyone who voted in the poll, whether it is hot or cold. The correct answer was hot, but thank you for participating. So yeah, if you got questions, toss them in the chat. Let's like hang out and, you know, move and groove and something else that rhymes with one of those words. Joe, are the glasses broken? The glasses are not broken. They're chilling. Does everyone know the secret about the glasses? Does anyone want to put it in the chat if you know the secret about these glasses and why I wear them? Let me know if you know. Let's see. OLM2 next to Joe's house. Are you still using power hatches to power on your rockets? I am not. I'm using... I can link if you want, or you can just look it up. It's from a company called FingerTech Robotics. They are... it's like 3 30 seconds or 5 30 seconds hex wrenches that are like fully engaged power switches. So basically, it's just screw terminals that you power on. Yes, and Liam and Derek and I think a few other people know they are fake glasses. I have really good vision, and I wear these because I like the way I look. And my friend Liz a long time ago said you should wear whatever makes you feel like a princess. And I don't feel like a princess with these, but I like the way I look at them. And two, I noticed when I started wearing the glasses, people stopped commenting so much about how they were like, do you know that you look like Elon Musk? And I was like, yeah, I have heard that 1,000 million times. But they commented it less with the glasses, so I stuck with it for a little bit. But I don't know. They're fake. Let's see. Why are the spin cast liners so much thicker than the phenolic? Don't you lose propellant mass with that? Yes, Matrix. They are much, much thicker because I didn't know how well they ablated or insulated. So I poured an unbelievably thick liner for the first spin cast test so that I could figure out how much that ablation rate was with a lot of safety margin. And now that that's done, I can pour a thinner, more efficient liner. Have you made a simulation for the space shot? Nothing beyond Open Rocket right now. Are you an aerospace engineer? I engineer things, and they are space adjacent. They are rockets, so I would say yes. What is the status on the video about cameras inside the rocket? Filming an HPR launch is one of my favorite videos for you, and I'm interested in what you use. Thank you, by the way. I liked that video. I did not... most of the people on YouTube did not seem that interested in the video, but I really enjoyed making it. The onboard camera video is basically done filming. I need to write the script and talk about it, but I have now figured out how to make GoPro Hero 10s work in a rocket, and although it is a big challenge, the video will come out probably in the next 2 or 3 months, is my guess. Ba-ba-da! Do you know you look like Elon Musk? Whoa. Are you serious? I did not know that. Oh my God. Yeah, you're the first person to tell me. Have you thought of, hey, what's up, Neutronium? How are you planning to make the space shot nose cone? I think about that a lot. I would like it to be fiberglass, so it's RF transparent, but that means it's going to have to be pretty thick. And, hello. Oh my gosh, what is happening? Maybe I have to detach the hard drive. I've been having problems. I'm trying to send everything through one USB bus. Sorry, guys. I've been trying to send everything through one USB splitter, and when one of my hard drives spins up, I think it causes problems on the mic. Yeah, sorry, folks. So what was I answering? I don't remember. Can someone remind me? Oh, the space shot nose cone. Yeah, I think fiberglass layup. It would be cool to use those sleeves. I know people have had good luck with fiberglass and composite sleeves to do nose cones. I think the big problem is wrinkles in the cone, and the sleeves seem to be a way that you can work around that. And then I think conical, and I think there's probably some post-machining that has to happen. Why don't you work in NASA or JPL or something? This seems to work well enough, and I have a really good time doing it. If it stops working, then that would be great. It's a little bit like when someone does really well on YouTube, and then people are like, "Why don't you go get a Netflix show?" And it's like, why would I accept? Why would I accept to have less control over the stuff that I do when I have a successful job that's going here? Not to say that the other career paths aren't valid, but I'm having a pretty good time, and if I start to burn out or feel like I'd rather work, on some other problem that is really adjacent to BPS. That's sort of why. Are you going to be talking about a Kalman filter in your next video? Kalman filter is the only thing I can't fully figure out software-wise. No Kalman filter for a little while. Yeah, sorry. I wish I had a better answer for you on that, but no Kalman filter for a little bit. I built my own rocket, but I can't write the telemetry program. Can you help me? Thank you so much. I cannot write software for you, but I can point you to some stuff that I have used. I used a language called processing. It's literally just called processing. And if you look up, there's a video on the BPS YouTube channel. I will just get it for you now. Sprite ground control on BPS. It's a 19-minute video. It is really, it's not good quality, but it shows you how I built the telemetry software for Sprite. And then this is the same kind of technique that I used to build the other telemetry stuff that I used, or that I currently use. Hey, do you and Xylofoxlin have a competition for whose explosive cabinet is full of stickers first? We do not have a competition for that, but I love putting stickers on my flammables cabinet. I watched a bunch of, the old school videos. Unbelievably annoying that every single video has 15 plus Elon lookalike comments. It is what it is. I mean, you can't change it. It's still like, people could be saying way worse things. I don't get like racist comments. I don't get like sexist comments. I don't even get any like hate comments other than like a couple of, weirdos. But like, if the worst thing that happens is people go like, do you know that you look like Elon Musk? I guess, it's not that bad. Let's see. Nose cone. Right. Sleeves work great. I have made one with them curing in my shed. Oh, cool. Nice. Joe, can I write to you privately about something? If so, where? Yes, I have a website, BPS.space, and if you can find the contact section of the website, there's a contact form on there. If you send a message, it goes right to my inbox. I can't guarantee that I respond to all of them, but I will see it, and if you want to ask a question, you're welcome to. Machine the nose cone out of stainless. No. Pass. That's a hard pass there, bucko. What is the biggest concern or problem for the Space Shot rocket? It comes in waves. When I was doing a lot more propellant development, all of the propellant was a concern. I did a bunch of GNC tests that I'm about to publish some videos on, and now that is a concern. I am at, like, telemetry is a big concern. I have problems with telemetry. Like, my stuff is not smooth. People who have seen me at FAR or have seen videos, like, I routinely lose connection with my rockets, and that is not a solved problem. It's mostly not solved because I haven't put effort into solving it, and that's the case for a lot of these things. It's as soon as I put effort into it, all of the problems with the Space Shot are solvable problems. I just need to put the effort in to solve them. So nothing is like inherently that concerning. It's just that, I will be worried about the things that I haven't solved until I have solved them. Right now, the thing that's mostly in my head is recovery dispersion, which means for the second stage, the booster's not so big of a problem. For the second stage, if we point, 1-2 degrees off of vertical, or there's a little bit of wind at high altitude or at weathercocks or, whatever, that recovery dispersion, and we talk about it in the next video, could be 10, 20, 30 miles. A friend of mine, Kip Daugerdas, who, if you've been on YouTube rocketry stuff, you've probably seen his stuff, but Kip does a bunch of high altitude flights. He flew to it was 150,000 or 200,000 feet in the spring of last year, and his second stage was 10 or 11 miles away. And that is not even, that's half of where I want to go at minimum. I would like to go 400,000 plus feet. And so recovery dispersion is a big concern. And I have some thoughts on it, but we haven't, it's definitely not a solved issue. Okay. Gonna acquire some Inconel for the nose cone tip. I don't know that you need Inconel. I know that some folks do it, but I think stainless for the nose tip is fine. I haven't run sims on it, but as long as it's not a super sharp point, and if it's a super sharp point, the sharpness will go away with the flight. Sharp points heat up really, really, when you have a sharp bleeding edge, the heat is much greater than when you have a rounded edge because A, there's more thermal mass, and B, the oblique shape changes, and so you get less like peak heating at one point. Okay. Yeah, I think stainless for the nose tip is probably fine. When will the video on EB Debris 2 come out? Well, so EB Debris and EBDB are a mess at this point. I did fly EBDB last fall. I don't think I'm going to talk about that flight until we do the video on onboard cameras, because that's kind of part of it. Part of that flight, Ava didn't work, but it's like not an interesting enough failure to make a whole video about. But the GoPro also didn't work, and that is an interesting enough thing to talk about in a video about onboard cameras. Do you still sell flight computers? I do not. I would like to, but hours in the day, and it's just the way the cookie crumbles. What are your results from the GPS investigation? I am working on a payload for my college's IREC team and currently battling GPS radio working. Dr. Coconut, 1245. That's a beautiful first name. How did your parents come up with that? So the GPS problem for me has been solved with obviously like carefully thinking about where your antennas are and carefully thinking about where your antennas are. But for me, it was about acquiring GPS satellites in a really quiet environment, which meant that I boot up the rocket and now I leave it for 10, 15 minutes with no telemetry at all. I don't have any sense of what's going on in the rocket. I just give it a really quiet RF environment for the GPS stuff to pick up satellites, because depending on how well versed you are in GPS, when these signals are coming down through like the ionosphere and the troposphere and all of that stuff, they get all messed up, and the signal to noise ratio is like really, really high, which means that really, really low. So like the signal is here in power level and the noise is like here, and then so the noise floor is really, really high. It's difficult to pick up those signals, but once you've acquired them, it's easy to hold on to them. So if you pick up GPS satellites in a quiet RF environment, then you can turn on your telemetry radio, your cameras, any other big noisy stuff, and it's easier for your GPS, now that it's downloaded almanac data, it's got the ephemeris stuff from the of the satellites and where it can expect to look and hear different satellites. So it's easy for it to hold on to satellites and keep picking up new ones once it's established a connection. So you establish it first, and then you turn on your loud stuff. What did Insta360 say about EBDB? They were fine with it. I mean, I thought they were gonna be a lot less happy that I like lost one of their cameras in the desert, and they were like, "Oh my gosh, that's great." Okay, I got to catch up on some questions. Joe, first foray into building an APCP motor. Experience aside, thoughts on starting with the 4-inch motor? I don't think 4 inches is a terrible scale to start with, but it depends on like what your mixer is, who you're working with. Definitely make sure you've got a mentor to work with. And yeah, I mean, I don't think 4 inches is terrible. I don't think I'm also a good person to ask for how to start with that, because I started with 6 inches and then had to work backwards, going to 4 inches and then even further backwards to go to 2 inches. Not to say that like the more you build motors, the bigger they get always. I would really recommend starting with 2-inch. That is the way that I should have done it. Pour a bunch of, propellant into some low-key experimental cases, some 54 millimeter cases. You can make pretty good motors, and like you can get really good data from that scale. You'll spend less money. You're gonna blow up a couple of them. It's less painful to blow up small motors, and it's easier if you're using a KitchenAid mixer. A buddy of mine made a P motor using a KitchenAid mixer, and he had to do every single grain. It was like 12 mixes. Neutronium knows who I'm talking about too, but I would say start at 2-inch. I don't think it's impossible to start at 4-inch, but you'll save money and it will go faster at 2 inches. Okay, here we go. Julian says compression molded conical nose cones. Julian, I can't compete with you on any composite stuff, though. Not all of us can be built different like you. Let's see. There's a lot of good stuff in here. Have you considered using something commercial like a Blue Raven altimeter as a backup for the space shot? 100 million bajillion %. I'm flying the space shot with backup computers. Yeah, that's non-negotiable. There's like an amount of, what is it, hubris or something? There's it's not self-confidence if you only fly with one computer and you wrote all the code for it. It's just ignorance. So yeah, no, we will have commercial backup computers. Okay, stop asking about the onion. I'm going to block you, dog. High altitude winds will murder dispersion even with a perfectly straight boost. I had a flight where it was going faster sideways than it was descending on drogue. Yep. That's what happens. High altitude winds are bad. They're bad for big rockets. They're bad for small rockets. Will the recovery system on the space shot be pyrotechnic? Don't know. Haven't designed it. LoRa is very long range but low bandwidth. Might be decent to transmit back GPS coordinates, but probably not full telemetry. Did you learn about aerospace and avionics by your own, or you studied in a university? I learned it by myself, but that's also kind of a misnomer, if that's the right word. Saying you're self-taught, at least the way that I did it, I would say I was like self-taught for the first 2 years, and then I found enough people who were willing to help or talk to me that I was like taught by friends. This is why I think FAR is a really valuable resource, or going to any club launch is a valuable resource. You learn 1,000 times more when you talk to other people who are also trying to figure stuff out in your field. So I'm like self-taught, but actually it's just that I surrounded myself with people who know things, and then like a sponge, I just like try to absorb as much as I can. Okay, moving on. Are you planning a video about the GPS anomalies? Yes. Next video, guided recovery using fancy parachutes. No, sorry, I'm not doing guided recovery. There are a certain number of miracles that I can accept in a project. That is too many miracles. Okay. What TPS on the nose cone? I don't know. I don't have a plan for that. There are a bunch of questions about the space shot that, like, I'm just going to give you the same answer every time, which is like, I don't know. I haven't designed it. We're so far off. We're years away from the space shot, and that's disappointing, but also it's the reality. Like, I want to build a big, complex rocket, so it's not happening this year. It's not happening next year. In all likelihood, if it happens in 2026, it's maybe late 2026, and you know, knowing the way that schedule works, it's probably later than that. I'm not trying to get to space quickly. I'm trying to do it in the way that I want. So we're going to take our time, and so that means that a lot of the things on it, like TPS and whether we're doing guidance and recovery and, you know, all that stuff, these are problems that are solvable, and they have not yet been solved. Okay, did you finish work with Ryan Hansen Space, or was it canceled? Ryan was really nice over email, but we realized that, or I realized that it was not really a good fit, because Ryan does hyper-realistic renders, and what I mostly wanted was just an animation of telemetry data. I didn't care that it looked super realistic, so it wasn't really a good use of his time, but he was really nice, and it just probably wasn't a good fit. Excuse me. I also want to be an aerospace engineer, but it is very, very difficult here where I live to get into college for aerospace engineering. Yeah, I would say that there are ways to do it through the more traditional approach of going to college, going to university. I have had success doing it without going to university. I will tell you, it's kind of a trade-off. It's really hard to get into a good school to study aerospace engineering, or it's at least somewhat hard. I didn't try, so I don't really know. If you don't go to school for aerospace engineering, it will be a lot, or for anything related to that, it will be much, much harder to get a job without it. Like, going to college is like a hot topic right now, and whether it's worth it depends on your field and your goals. But you're going to trade off if you don't go to school for a relevant field. It might be easier to get into school, but it will be harder to get a job. So it depends what your end goals are. I also think going to school for aerospace engineering does not mean you do aerospace engineering. Like, there are people who do aerospace who studied EE, they studied Mech E, they studied systems engineering, they studied I don't know, aero engine, I don't know. You don't need to go to school for aerospace to work in aerospace. Okay, let me catch up here. What kind of FAA clearance do you need for a space shot? You need a Class 3 waiver, among a couple other things. You might also need a land use permit. You might also need stuff from your, like local fire department. If you're flying, there's all sorts of stuff. There's a decent amount of paperwork. Let's see. Would you consider a nitrous oxide hybrid engine a safer solution than a solid motor? No. I hate hybrids. Don't do hybrids. It's not worth it. I mean, it depends what safer you mean. Safer is all subjective. Depends on your experience. It depends on the people around you. Depends if you have a mentor, what your mentor is comfortable with, right? Like, I can make solid motors with a degree of safety that I am personally comfortable with, but it's because at this point I've worked with other people. I've talked to a lot of folks. I could not make a hybrid safer than I could, like, nitrous oxide, by the way, is like really spicy in terms of like phase change stuff and how angry it gets if you don't pay attention to it. So like, yeah, I don't know. Safer is not objective. Okay, sorry. Pookerly, thank you for the super chat. Hey, quick question. Where I live, buying motors is very expensive, so I'm planning to make my own sugar motors. Do you think it's worth it? No. Sorry. I am sorry to be crass about this, but to put my response of do you think it's cheaper to make your own motors into words, the answer is it's not. You will blow up enough motors that it will not ultimately be cheaper in the short run. It is a bummer that motors are expensive, and it is very expensive to start making your own motors because you need to factor in the hardware you need to make them. You need to factor in your own time. I mean, depending on how you want to count that, if you enjoy like doing this with your hand a whole lot, maybe that's something you like. I don't think it's worth it to make your own motors if you're looking for it to be cheaper, unless you're building at a really, really big scale or unless you're making a ton of motors. Okay. What are your plans for long-distance communications for live footage? I don't have plans for live footage on the space shot. BPS space shot or Artemis 3 first? Artemis 2 is what? Next September? When's Artemis 3? Artemis 3, they want to land on the moon, right? I'm not super well-versed in the Artemis program. September 2025 for Artemis 2. Does Artemis 3 have a date? And like, if it has a date, it's clearly not going to hold. Like, there's someone, yeah, toss it in the chat. Why don't I just look this up? I have the internet. Artemis 3 launch date. September 2026 for 3. That's the first crewed mission of the Artemis program. So that requires crew to Orion. That requires Starship to be working. That requires Starship with life support to be working. I don't think that's happening anytime soon. I think Starship will work this year. I think it'll make it to orbit, but like, there's no way. Like, Eclipse systems are complicated and difficult, and that is an enormous volume to build an Eclipse system for. Yeah, I think I'm space shotting before Artemis 3. That doesn't. We'll see. You know, maybe someone clip this and then tweet me in like 3 years and see what happened. Are you planning on doing more shorter fun projects like the silo launch rocket in between now and the space shot? I mean, we have the meat rocket this summer. That's hopefully finally happening. That's a shorter project. I'm hoping that takes about 2 or 3 months to build that vehicle. But then, yeah, and then like there are more shorter projects, but they are all in service of the space shot. Like, one of the things we want to do on the space shot is eject a little cube, like like poop a little cube out the side, and then the cube like looks back. It uses a couple of reaction wheels to stabilize, and it looks back at the rocket to get third-person footage of the rocket. That in itself is like a great, tiny, manageable size project to build the deployment system, build the cube itself, build the way that we find the cube after, the way that it comes down safely. That's a tiny little project. Excuse me. I don't know that there are any like cardboard rockets that are coming soon, though. Just got on. Will you design and make all the electronics and write all the code for Space Shot? No. Some of the electronics will be COTS, or commercial off the shelf, but those are going to be backups. My plan is to put Ava in primary control of the Space Shot, and so that is all my own electronics and own code. But I don't trust myself enough to not also put other stuff on there as a backup. Is the meat gonna be outside of the nose cone? Yes and no. The meat is both outside and inside of the nose cone. What's the highest altitude you have sent a rocket, and will the meat rocket go higher? The highest altitude is about a little below 10 kilometers, and the meat rocket will go higher. His cat is sick. He needs super chats. Guys, that is true. My cat is very sick. He has been sick for the last 2 years, 3 years maybe. He needs your super chats. That is the only way. I took him to the vet. The vet looked at him and said, "This cat needs some super chats." So, good point, Liam. Thank you very much. I am getting into rocketry and wondering if there's a kit you recommend. I love watching your videos. I'm a teenager. Thank you. I would go pick up anything from Estes, basically. There are, depending on your own comfort level with working with it sounds silly, but like arts and crafts, glue, scissors, knives, stuff like that. If you feel comfortable with that, then maybe pick up one that requires you to build a little bit more, maybe cut out your own fins, that kind of thing. But I think Estes has a lot of great kits to get started, and you can learn a crazy amount at the small scale for pretty cheap. That's what I did too. Even when I got started and I knew I wanted to land a rocket, I started by buying a couple Estes kits and re-upping on those videos didn't make it public, but one day they will. In the summer before I started doing TVC, I flew a bunch of Estes kits. Yeah, it's being delayed again and again. I think they said net 2026. Yeah. I don't think Artemis is happening. I mean, landing on the surface of the moon, I'm skeptical it happens before 2030. Let's see. No live footage. Yeah. Well, I mean, whatever. The live footage doesn't really matter. Putting in a ton of effort to get live video from space doesn't. The quality wouldn't be that good. With the resources that I have and the tools that I have, I don't think the quality would be very good anyway. But the whole flight for the space shot is 10, maybe 15 minutes. I don't know. I haven't looked at it in a minute. And as long as we find the space shot afterward, which I think we can, there's quite a bit I can do to ensure that happens. I don't think there's any value in having live footage. I mean, there's very big value in having live telemetry. That is for sure. But pulling live footage is not something I'm interested in. Would it be a valuable idea to build a hybrid solid-fueled rocket engine that initially burns the inner solid fuel grain and then later controllably burns the... No. That sounds like all of the bad parts of every part of propulsion. No. Now that you can make your own propellant, will you continue using commercial motors on other projects or just make your own from now on? I'm using a commercial motor for the meat rocket. And I think after that, it's probably, it depends. On the small stuff, I see no value in making my own motors. There's value to my time too. And it's, I can't just buy a 6-inch motor from Aerotech, not cheaply at least. And But like, I did a bunch of flights earlier this year that used an L1000, and it's great to like click order, and then the motor shows up, and then I take the motor, I do almost nothing with it. I like put in a little ejection cap, and I put it in a rocket, and then I put an igniter in. That has a ton of value over spending 2.5 to 3 to 4 days mixing up a batch of propellant, waiting for the ammonia to come out, casting the batch of propellant, waiting for it to cure, pulling the mandrel, making sure the voids are good, making sure the density is high, fabricating a nozzle, integrating a nozzle, fabricating a forward closure, integrating a forward. Like, there's so many parts to making a rocket motor that it is, on the small scale, it makes more sense to just buy them. At least for me. Okay. My warranty replacement i500 just arrived. Thanks, Aerotech. What's the plan for TLM on the space shot for telemetry? It will be a COTS system. Right now, I'm using an RFD 900 with pretty good success, and there's ways that you can boost that signal beyond 1 watt, so long as you comply with FCC stuff. And my plan is to just stay at 900 megahertz for AVA, boost that power way up. We'll do a bunch of range tests to make sure that everything is, above board. But basically a boosted RFD 900 for AVA. And then for the backup stuff, I mean, a Telemetry is always nice. And that can have, what am I trying to say? That's on 400 megahertz. I don't know how well that goes up to space. I would have to look at the power level that they're transmitting at. But yeah, and I currently use an RFD 900 for live telemetry. Okay, let's see. Are you planning? Are you going to do another watching Tim watch a rocket, maybe with NSF? I don't know. It was really funny, and I feel like the funniness is the surprise on Tim's face when he realizes what's happening. Maybe. I mean, the shitpost streams on the Joe Barnard channel are like, they're a lot of fun, but I feel like you got to keep it fresh. You can't do the same thing. Eric says that has to be the wrong pronunciation, and I'm right. SDs. I've heard SDs. I've heard Estes. Who knows? I met Vern Estes once, or Estes, and I should have just asked him, and I did not. I'm going to give a thumbs up to this cat support. Thank you, Robert, for your €5 for my cat. He has started to feel better because of your super chat. So everyone say thanks, Robert. Robert super chatted €5, and my cat, who needed super chats to stop being sick, he's healing now. Please make a how to make a parachute video. Sorry, that's a no from me. I don't know how to make a parachute. I'm going commercial on parachutes for the space shot. I am not making my own. Let's see. High altitude balloon prediction websites would be useful in simulating where your space shot would land. Yes, and they're useful for much lower altitude rockets too. We've done balloon sims for Lumineer and for Send It too. High altitude balloon simulators are great for predicting how your rocket will descend. Have you considered some form of ceramic for the nose cone? It may have some weight benefits. Weird shock resistance might be a problem. Or wood shock resistance. Yes, I have not considered that. You actually don't want weight benefits in the nose cone. You want a heavy nose cone that helps with stability. So I don't really see a value in doing ceramic for the nose cone. Stainless seems fine for the tip, and then fiberglass or carbon composite if you don't care about RF. Let's see. Ooh, what's up, Jacob? Glenn, rocket engineer here. Great stuff on your channel. Keep it up. Thank you, Jacob. That's very kind. Good luck. You guys got big stuff coming up this year. Let's see. How many of your motor parts are reusable from motor to motor? I'm assuming they have the same geometry, of course. Josh, that's a good question. On Simplex, so I have Simplex V1 back there, I was able to reuse the forward closure from that on Simplex V2, which I just fired, and if you want to see, is on this channel under just the videos. It's the last thing I posted. The forward closure is the exact same as for Simplex V1. I had to make a couple of mods, but it's the same piece of aluminum. And it's actually the same piece of phenolic as well that insulates the top. But, sorry, it's actually the same exact igniter bolt too. I took the igniter bolt from Simplex V1, bored out the RTV, refilled RTV with new igniters, and then cast new MTV on top of it. And it's the exact same. The nozzle I was going to use, and then as I was looking at the nozzle, I was like, I can just do this better. And so I took a day and a half or 2 days and remade the nozzle. The case cannot be reused. For Simplex V1, it could, but now that we're doing spin cast liners, the case can't be reused anymore. But the case is actually like not that expensive in comparison to the other stuff. Let's see. If you had sufficient funding, would you expand BPS after the space shot to orbital, or would you rather work, for a different aerospace company? I mean, it would be really fun to try and do an orbital shot. I just don't think, like, you can't do it as one person. I don't think you can do it as one person. And like the space shot is really expensive, but it is possible to offset that with Patreon and with ad revenue and with sponsors and with merch. And, you know, worst case, I sell some feet pics on OnlyFans. I'm not against selling feet pics, but Orbit is like, I don't know, man. I think the paperwork alone to like, that's a full-time job for like 5 people to do the paperwork for that. And like, I don't have the money to, like, YouTube is not going to make, at least the current form of YouTube is not going to make me the money to pay 5 people to do that, as well as probably another 5 engineers or 10 engineers to work on that. So I don't think Orbit is in the cards. I bet there's a bunch of other cool stuff we could do. And frankly, I'm not going to think too hard about it. The space shot is such a big, lofty goal right now, and it's not going to work on the first try. So, you know, I think it's sort of getting ahead of ourselves here. Neutronium says, what about Kate for the space shot? Kate is also at 900 megahertz, so I'd be a little worried about crowding the frequency with Kate, but I do know that Kate has worked to 124 kilometers. And strangely enough, I'm pretty sure Kate is 1 watt, 900 megahertz, which doesn't check out. Like, that math doesn't math in my head, and also in like RF bandwidth calculators. So I don't know what's happening, but I've seen Kate get signal from 124 kilometers up with 1 watt on 900 megahertz, and I don't know how they're doing it. I will say Vern Knowles, who does Multitronics and Kate, is basically a wizard. He's like one of the smartest people I have met. So he may just be really, really good at RF design. If you had to redo propulsive landing now, do you think you could make a more suitable motor, or would you still buy one? I would still buy one. I don't have the consistency and process control to make motors that burn that consistently. And also the motors that I make leave slag on them. I would have to make an ammonium perchlorate motor that has no metals in it or fully combust the metal, and no metals is more likely. Yeah. Anyway, it's an interesting thought, though. It would be fun to try doing more propulsive landing stuff after the space shot. Like doing a liquid hopper. If you guys follow Gruyere Space Program, however you pronounce it, those folks are awesome. They've got this little hopper called Calibri, and they're going to fly it probably soon. That's a great project, and it would be fun to try something like that. And actually, I will say, I have talked to them a little bit, and I don't think it makes sense right now, but the Mojave Air and Spaceport, where Maston was, where Virgin Orbit was, a bunch of other people, renting a warehouse there is like not as expensive as I thought it was. And so maybe after the space shot, if we can like raise a little bit of money and rent a warehouse for a while, we could do like some liquid hoppers. Do I have a hand radio license, or are planning to get one? No and no. I mooch off my friends for ham radio license stuff because you have to publish a bunch of personal information about yourself when you get a license, and I see no reason to do that. So I will just work with friends who are licensed and operate under them for the time being. Do you sell rocket motors? No, and I will not. I promise you, I will not be selling rocket motors. I will not make you a motor. I don't care how much you want to pay. There are legality things that I will not mess with there. And also, like, I don't know. It's making motors sucks. The big ones especially, like, it's a bad time. I don't like doing it. I've gotten okay at it, but like, you got to have some good podcasts, and you got to just like really make peace with boredom and stress. You look at, I have a ring that I wear. It's called an Aura, and it tracks all of my biometrics. So like inside of the ring, there's a bunch of sensors and stuff like that. So it tracks my heart rate, blood oxygen, like whatever. And I can find, let me find you a day. Let me find the day that I mixed Simplex V2. And I'll just show you the stress level on that day. Sunday, Saturday, here we go. That's got to be Wednesday. Is it this day? Yeah, okay. Can you tell when I started mixing? Can you tell when on this day I started mixing a rocket motor? Because I can. This is my heart rate. And so basically, after a certain point, after about 2 p.m., my heart rate doesn't really drop below 100 BPM until we're done mixing. And then the next day is the same, except I wake up and I mix basically all day. And it's just above 100 BPM the whole day. So it's not fun. Like, it's not a good time to make big rocket motors. So I'm not doing it for money. Okay. Sorry, I got a little behind. Did Simplex... Okay, wait. Sorry. I got to speed up. This is great. I'm having a good time, y'all. Thank you for joining me. How will be... Does that make sense to everybody? Good Lord. Ever thought about doing a Starlink terminal for data transmission during flight? No, I have not thought about that. I don't think I can fly a Starlink terminal. I don't think it's small enough to fit in my rocket. But it seems to work great for SpaceX. It also seems a little inefficient for what I'm looking for. How will the fins actually be attached on the big metal case rockets you're building? Excellent question. Excellent. Call him a chicken the way that was excellent. Man. I'll be here all week. So I don't know yet. Bonding to aluminum is kind of tricky because aluminum very, very quickly, once you strip away, it forms an oxide layer. Aluminum is actually like a very reactive metal. But it immediately forms an oxide layer that protects the outer surface so it doesn't keep reacting and oxidizing. The oxide layer, it's really easy to bond to the oxide layer, but the oxide layer is only weakly attached. Someone should correct me in the comments if I'm wrong. But as I understand it, you can strip away the oxide layer with chemical etchant. You can do it with sanding. You can, I think, do it with plasma. I got a plasma. My buddy Sam Austin made a plasma treatment machine, and I traded him 2 rounds of phenolic for a plasma treatment machine. So we're going to run some experiments on that. If that doesn't work, the other way you can do it is you chemically etch it, and then you can do a chromate conversion, or sometimes called iodine, and that actually converts the surface of the aluminum so that it doesn't form that oxide layer. You're not attaching to the oxide layer. Like anodize is attaching to the oxide layer, but the oxide layer is still weakly attached. A chromate conversion is, for what it's worth, super cancerous to actually like work with it, but really, really good bond with that. So I will either do that, a chromate conversion. I'll send it off to a service to get chromate converted or iodined or whatever, and then I'll bond to that. Or we will do a composite fin can. I'll just wrap a bunch of carbon whatever around a mandrel, and we'll do a full fin can that's separate from the booster, and then we'll slide the fin can on. I got to speed up on these questions, dog. Sorry, I'm quite behind. Ceramic coatings over fiberglass for some up. Yeah, okay. Sorry, Neutronium. I'm going to skip over that. But it does sound cool. What should I do after small Estes rockets? I've made and launched a bunch and not sure what's next. Depends what you want to do. If you want to make flight computers, maybe make one and fly it in an Estes rocket, see how it does. You could try logging data, try deploying parachutes with it. And also, if you're a member of your local NAR or EEE chapter, I would say, like, make sure you're going to those launches, talk to people, see what other people are doing. Something's going to pique your interest probably. Maybe it's getting your L1. That's a great exercise. Getting your L1 is awesome, although like the rockets start to get really expensive then. But you get to go really high and fast. Are you planning to sell AVA boards? Are you planning to sell AVA boards in the future? I don't have active plans. I'm not against it. I'm thinking about it, kind of kicking the idea around. Did Simplex V2 perform as you expected? Yes. We will make some videos about it. I'll have more details soon. Orbital gets you FAA for return question and debris problem in-house. I mean, yeah, if you're going Orbital, like, there's so much conversation that has to happen with the FAA. It's not like the FAA is going to be like, why did you do this? They're going to, like, there's... that is not the problem. If the case can't be reused, why make it metal? You could buy fiberglass casings online and filament wind them. What's the benefit of metal non-reusable? I mean, not everything I do is the most efficient. I don't want to like keep adding complexity, and winding my own cases feels like I'm a little bit asking for that. I know the metal works, you know, I know it's predictable. They're not that expensive. Yeah. Just do the liquid motor and go to orbit. No, that's not how that works. Feet pick pund. Thank you, Eric. Wow, there's a lot of likes on that. Y'all need to chill. But I am not against selling feet picks if it comes to that. We're going to try to not do the space shot without needing feet picks to fund it, but maybe as a bit. Maybe I'll sell like one feet pick photo. Okay. What would you recommend it as a first small flight computer, just for telemetry and maybe firing shoots, no TVC? There's all sorts of cool things. I would actually recommend hopping in the r/rocketry Reddit Discord and asking people on there. There are a lot of good rocketeers who have more experience than I do with commercial altimeters, and I would ask there. I have things that I've used. An Easy Mini by Altus Metrum works. I know people have good luck with Stratologgers. I'm going to try one of those new Fluctus computers soon. There's all sorts of stuff. And it depends on your goals and your budget. Have you considered making a rocket out of blue tape? Yes, I think it'd be a fun project, but I don't want to do it right now because I need to make a bunch of serious videos first. Since Aerotech has made an H-14, any thoughts on flying Sprint again to get higher TVC flight? Yes. I would love to do a like multi-stage big TVC thing from far where we try to get to like 10 kilometers on like a finless rocket or something. But no plans, at least right now. Would you do the LM? I don't know what the LM means. I've got the same question as Philip. Where do you go from Estes rockets? Okay, answered that. Thumbs up. Anyone want confetti? Yay! I love that. Let's see. It is hot. How many years it took to learn everything about rockets and build your very first rocket? How did you learn everything? Okay. I get a bunch of these questions that are like, how did you learn the stuff that you know? And I think the best advice is like, surround yourself with people who can teach you it. That's it. I can't concisely tell you how I learned the stuff I know. There wasn't like a course I took or anything like that. And frankly, you're like, a lot of the stuff that you see online is only the stuff that works. There's stuff that doesn't work online, but like, I don't know that much about amateur rocketry. I know a lot of stuff about what I talk about, but like, I haven't. There are a lot, like there are a lot of people who know a lot more than me about amateur rocketry, and I think just surrounding yourself with people who know more than you is the best way to learn. I don't have a really elegant answer to that question. Yeah, the only okay. How did you license Epsilon 3? Oh, I mooched off of a friend. My friend Charlie has an Epsilon 3 license, and I can't remember how he got one. He works at like a real space company, though, and he just added me as a member to his organization. So actually, I'm just using that. Epsilon 3 is really cool, but it is not in my budget. What is it, like $1,500 a year or something? Epsilon 3 cost. I don't pay for it. It's $2,400 a year. Epsilon 3 is like worth it if you're a big company. Like, you know, you'd be shocked at how much enterprise software can go for. And I really like using it. It's a good software. I would not pay personally, it would not be worth that much money a year for me. So I'm mooching off of a friend who has a license. Is the propellant directly poured into the liner inside of the case? Yes. Sorry, Joe. Gotta go. I have a motorcycle ride calling my name. Sounds fun. Be safe, man. Thanks for joining. Separate fin can would be good in this case. Do you think... Oh, good question. Do you ever think of X-rating the motor castings to check for void? I'm pretty sure there is someone in the NDT, non-destructive testing industry, that could help you out. Yes. I think I have to check my Twitter DMs. Oh, okay. That's not what I thought. It doesn't matter. I think there is maybe a possibility that we can X-ray a motor. I don't know that I'm not gonna get an X-ray machine. I don't think so. I also don't know that I have the space for it. But yeah, it would be really, really cool to X-ray a motor. It is not strictly necessary to check for voids because A, the propellant that I have now is pourable enough that I'm not expecting big voids, and B, I do a lot of density checking after the fact, and density checks will alert you if you have like a bunch of big voids. Okay. Excuse me. I'm going to avoid some of these questions, not because they're bad, just because, you know, what was the first rocket you flew? It was an Estes rocket. I don't remember it that much. It doesn't matter what the first one you fly is. After the space shot, do you have plans for the next project? Not really. The space shot's far enough and ambitious enough that I don't think I'm in any... I'm in no hurry to like fill the time after the space shot. Maybe my plan is to take a nap. Cooking with Joey B. when? I don't know. I haven't had the itch to do one in a minute. Maybe we'll do one soon. How space capable is Ava? It's been to space. It has not returned in one piece, but it has been to space on a different flight. Okay. Shouts out Apple Confetti. Dude, I know all the Apple commands now. I know the rain, right? Come on. There's the rain. Then we've got balloons. Okay, then we have... This is lasers. There's obviously the thumbs up and thumbs down. This is a heart. I think this should work. Yeah, there we go. I love the Apple animations. Spin launch or electromagnetic style launch, future rocket idea not for space shot. Too complex for me for non-space shot stuff. Didn't you want to do a Starship replica at some point? What happened to that? What happened to that is I got busy. I still would like to do a Starship replica, but it's quite a lot of work because I would like to, do active control and TVC, and the model is huge. And so I would like to, I have ambitions for stuff I want to do after BPS. It's not super clear, or let me put it this way. Doing the space shot is a jumping off point for a lot of other things. And while the Starship model is cool, it's sort of more of the same. The Starship doesn't the Starship model wouldn't require me to learn a ton of new stuff or really push my like technical limits. That's not to say an easy project and like I'm built different, but I've done TVC before. I would need to do some like low speed aero control, but that doesn't seem like a problem. So like, I don't know, maybe after the space shot, I have no immediate plans for it. I do think it would get a ton of views, but that is not a good reason to pursue videos. And every time I have tried to do a video to get views, it has backfired. What CAD software do you use? I use Onshape, and then for cam, I'm in Fusion 360. It's kind of a mess. I switch CAD softwares like project to project. It's definitely, it's not one. Let's see. If the propellant is poured directly into the case, what do you do if you make a mistake? Is the case just screwed? Yes. That's it. If you make a mistake, the case is screwed. But that would be the same thing if you poured directly into a liner. The liner would be screwed. And like a separate phenolic liner. The case wouldn't be screwed, but the case is actually very easy. I've automated the process of drilling the radial bolt holes. So making a case is basically as simple as like buying a tube of metal, putting it on the CNC for about 30 minutes, and then I have a case. So if the case is ruined, it's like, the much greater cost is $1,500 for propellant or $2,500 for propellant that's gone once it's cast. And the case is a couple $100 of metal. Is spin casting propellant a thing or only for the liners? I am only going to spin cast the liners. Spin casting propellant seems needlessly dangerous. The liner, can catch on fire a little bit, but then like will quickly burn out because it ablates itself and, or it will just like stay at a low grade fire that is easy to put out. A propellant fire is a self-oxidizing fire and literally cannot be put out in traditional conditions. So putting, 100 pounds of propellant spinning at 2,000 RPM on a lathe seems like you're basically just asking for an enormous amount of trouble. Okay. Have you ever thought about making an orbit mission with consideration for the FAA? No. William Osman has an X-ray machine, doesn't he? Yes. No offense to William Osman. I am not going near William Osman's X-ray machine. I mean, no offense, but no. What are the considerations for building a coupler for a staged rocket that is reliable enough for the space shot? That's a question that is too long to answer on a stream, but the considerations are many. There's a lot of bending load that has to go through that. Here's a good one. Are you time traveling Elon Musk? No one's ever told me I look like Elon Musk. Do you really think that? No one's ever said that, so that you'd be the first. I'm off to maintain some X-ray systems. Glad you were doing what you do. Oh, thanks, Smart Tiger. Thanks for joining. Can we take a minute and roast Spin Launch? You're welcome to. I mean, Spin Launch is whatever. We'll see what they do. All right, gonna skip some of these things. Make a rocket out of Legos. It would be cool to do like a Lego Saturn V, but it flies. But I don't want to fly my own because my own is like sentimental, and I haven't built it yet either. With the Starship replica, you would learn how to belly flop. Is that a really useful skill? I mean, it's not. Yeah, it's not really a useful skill for the space shot stuff that I want to do. But it's also, not everything I do has to be a useful skill. It's mostly just like I have a burning and intensifying goal to do a space shot. And so things that start to get in the way, like I would not do another hot glue rocket. Knowing how much time it took, like I'll happily accept a diversion of like a few months. And even like the meat rocket seems like it would be a diversion from the space shot, but it's not because it pushes us higher and faster. I'm going higher and faster than I've ever been. We're going to try to do aft fin control on the space shot to both control the roll axis and also point it directly upright. We're going to do some new camera stuff. I'm going to try to do a bunch of proper range testing for telemetry. So like the Meat Rocket is actually a pretty good test bed for some space shot stuff. So finding projects that I can do where it levels up the sort of BPS tech tree toward the space shot is good. And the Starship stuff doesn't really do that. The Starship is sort of a diversion. Do you plan on making more of your music available? I see the stuff you've posted on SoundCloud. Yeah, I will probably keep posting on SoundCloud. I just haven't remembered to do it in a minute. Valentine, I'm going to give you a thumbs up here, buddy. Thank you for the super chat. Did anyone tell you look like Elon Musk? Dude, you know what's crazy is like you're the first person to do that. Do you really think so? That's crazy. I'm going to think about that. Yeah, no, you're the first one. That's the new bit. That's how I'm going to handle these from now on. You talked about how explosives are inherently difficult to test because testing them destroys them. Are there any good alternatives to BP ejection charges? Yes. CO2. There are these little canisters. I think they call them whippets. People do them as a drug, and they are extremely dangerous. They will hurt you very, very bad. Don't do them as a drug. But CO2 canisters are pressurized to something like 800 psi, and so you basically just puncture those as a method to eject nose cones or stages or whatever like that. You're still doing it the same thing. You're creating a ton of gas, but instead of creating the gas, you're just releasing a bunch of pressure. And people have pretty good luck with that. It is also still dangerous. Okay. Just, I think, it's a different type of danger. Are you planning on tackling liquid propellant? Yes, is the answer. I would like to do a liquid rocket, but I would not like to do it anytime soon. I'm thinking that we do that after the space shot, if it happens at all. Let's see. Any plans for TVC on a bigger motor, movable nozzle? Oh, I would. Okay, I do think it would be really fun to either do a movable nozzle or I think maybe there is actually there's a decent chance that I try to do TVC on the first stage of the space shot. I don't think it's that high of a chance. I think it's pretty low, but having some small thrust vanes on the first stage of the space shot, like 3 thrust vanes, so we can do yaw, pitch, roll. I've been thinking about it. You do like graphite vanes, and it would really be so that we don't need a very long launch rail. You could even take off with no rail that way. But I don't know. It seems you have to worry about slag buildup on the thrust vanes, and I have a high aluminum content motor. It's also, for a Q, it's a short Q. It's a short and fat motor, which means that the aluminum is not burning as well as it would burn in a longer motor. So I don't know that it's really a good idea. Let's see. But if I was going to do TVC, it would be thrust vanes, not gimbaled nozzle. Not because the gimbal nozzle, the gimbal nozzle is hard, but it also doesn't let you control the roll axis. Nitrous is the drug, not CO2. Well, it tells you how much I know about drugs. Either way, don't, it's not good for you. I wouldn't do the CO2 either, and I think you probably get less of a high. All of the commercial CO2 systems use black powder to puncture the seal in the canisters, though. I didn't know that. I thought they used a solenoid. Huh, I didn't know that. Cheers from Sedan. Break it down half cat style. Yeah, half cat is the way to go for amateur liquids right now. SpaceX or NASA is, no offense, it's a dumb question. There are some dumb questions, and that's a dumb question. They are not the same thing. Any chance of breaking the space shot into 3 stages? basically zero chance of that. That seems... 2 stages is already... I already feel like it's pretty complex. All right. Well, unless anyone has any more questions, I mean, I'm happy to like stick around and answer some more stuff. I've got time. But things are slowing down a little bit. So if you've got more questions, toss them in the chat. I'm happy to hang out and, shoot the breeze. And we've also got a little bit of catching up to do because I delayed a couple of these Patreon streams. So we can catch up in another week or two with another one of these. But yeah, we've got a couple more questions here. Are we going to talk about Simplex V2's nozzle plug in the next video? Yeah, do you want to see the nozzle plug? Leave it in the chat. Yes or no? Do you want to see the plug for the nozzle? Give me a thumbs up, a thumbs down, a yes or a no. Does anyone want to see like the really fancy nozzle plug that I used for Simplex? It's very, very cool. All right, let me go get it. I'll be right back. Here it is. You're looking at it. I got a new 3D printer recently. I got a new Prusa. And it came with all of these foam pieces that are a little bit squishy. And the point of a nozzle plug for me, I don't really care about containing the pressure on ignition, at least at this point. I care about preventing any type of stray spark from entering into the combustion chamber before it can. So just sealing the ends with something that will prevent a spark from lighting the motor. So I chopped a section of this off, shoved it in the nozzle, and if you watch the static fire on this channel, it's the last video that I posted. If you go frame by frame, you should be able to see it just boom, out on ignition. Works well enough. Let's see. Are you planning a flight termination system for the space shot? I am not. I don't think there's a value in a flight termination system for the space shot. I mean, I don't know. It's far off. There's a bunch of Class 3 waiver stuff, and I envision that it will be complicated and maybe arduous to get the guidance stuff figured out for that in the Class 3 waiver. So it's possible that like part of that needs to involve an FTS. That the problem with FTS is like the FTS can't not work. So there also has to be a bunch of testing to make sure the FTS works. And I don't really want to do that. And that also, I've been thinking of getting, this is a lot of detail. I've been thinking of getting an explosives manufacturer license, not because I actually want to make like HMX or whatever the thing is, but like, or CL20, any of that crazy stuff. But because getting the license there's a bunch of licenses for making stuff in California that are a good idea to just have to show that you're trying to do things above board. And that is one of them. Will the second stage, some of these questions are a repeat. Will the second stage motor for the space shot be much different from the first stage? I don't know. Probably a little different geometry. Best way to separate a grain in a phenolic liner into multiple parts. Neutronium, can you put some more details into that question? What do you mean by that? Like, do you mean, so separating grains, I think you're not talking about this, but, you could use an O-ring to like keep, my fridge battery. Sorry. Yeah, I'm curious what you mean by that. Okay, what is the staging mechanism on the space shot? Wouldn't it be more advisable if you had fixed fins at an angle to spin stabilize? Spin stabilization is a good tactic, and it makes your cameras really, really dizzy. And I have a YouTube channel and want very pretty footage. And staging mechanism, I would like to make it passive. We will see. I would like to drag separate. We will see. Best part is no part. Best staging mechanism just falls off. Okay. Did you get the Prusa XL? I did. I got a Mark. Is it a Mark IV? They call it. I got the Mark IV and the XL. Prusa was actually. I was not planning on getting a new printer, and Prusa was kind enough to send one. And I didn't think I needed a new one. And then I got the Mark IV, and like that thing is crazy. It is really, really fast. It's a nice printer. How sketchy does rocket guidance start getting? You mentioned in the past that when you start being able to fire a rocket to a specific point, the lines between rocket and missile start blurring. I have so many thoughts about this. I also am going to put my phone on Do Not Disturb. This is crazy. Okay. I have so many thoughts about this, and most of them boil down to the same phenomenon. People... That's it. That's the phenomenon. I think it's fun for people to feel important. And I understand this because I want to feel important. And so if I want to feel important, one way that I can accomplish that is say, whoa, the stuff I'm doing is so serious that everyone is looking at me and putting me on a list because I'm dangerous or whatever. And I see that attitude a lot. There are a bunch of people on Twitter who have this attitude. There are a bunch of people anywhere who have this attitude of like, I'm so cool because the stuff I'm building is huge and like the FAA is watching me. And I'm not saying that like you can't violate a bunch of, you can't do like problematic stuff if you start building rockets that guide themselves. I'm saying, and this is not, I am not a lawyer. I have looked at those laws more than most people because I have become really, really worried about it at times. And so I have just like searched relentlessly. I have had a lot of calls with like export control people, and like you can get a free 30-minute consultation with a lot of law firms. I have used a lot of those, and I feel like I have an okay sense for where some of the limits are. And I haven't been contacted once about it. I haven't had a single person from the FAA or from, DOD, State Department, whatever, contact me and been like, you're close to the line. And I imagine that is probably what happens when you do something wrong. You probably get a little contact. Like Cody's lab did a bunch of stuff with uranium and he got visited. He got hit up by, I don't know, DHS or State Department or whatever, who showed up, or FBI, like, some organization showed up, not to be like, Cody, you're arrest, go to jail. You are arrest. They showed up to be like, yo, we want to make sure it's all above board and you're kind of close to the line. Yeah, exactly. FAA is watching me. Those peeps also misunderstand words like hacker. Yes, right. So I'm not saying that like I won't get visited. I'm saying I haven't been. And I have done a lot of really public guidance stuff, a lot of really public rocket control stuff. And some of it works really well. And I have not had someone show up and be like, what's the deal here, homie? So that's it. That's the thing. This isn't legal advice. I don't think that you can just do whatever you want willy-nilly and it will be totally okay. If you design a rocket that is going to like go up and then come down and try to hit a target and explode on impact, I think you will probably get someone who shows up and is like, do you want to talk about this? But yeah, I think like, I am very clearly and very publicly not trying to make a kinetic impactor. I am trying to make a rocket that goes up. I literally have a line about this in my next video. I can read it to you. We can give you a little preview. The line is, I'm looking to take a rocket that is 2 degrees off vertical and make it 0 degrees off vertical. We need tiny, gentle corrections, not some hard-turning anti-aircraft machine. I just want to go up. So I think like, there's probably a lot of value in being clear on what your goals are. I don't think there is any hard line, and I think that's also intentional. Anyway, I could wax poetic on that for a million bajillion years. Let's move on to the next question. Phenolic or paper liner? Phenolic, although paper and phenolic are not, they're apples and oranges a little bit. Like, you can have a paper phenolic liner, because phenolic it's like in a part of a resin. I usually use linen phenolic or canvas phenolic, which is a little less brittle, but I think the thermal properties aren't quite as good. Where is FAR? That is a question for Google, my guy. No, I'm not going to shame you, but I will say there are dumb questions, and a question for Google is not a question for me. What if you fly a test motor? I don't know what that means. Vampire ketchup rocket. Those are for sure. Those are some of the words of all time. That is for sure. Only reason for FTS on the space shot would be to prevent violating a waiver, right? Going outside the flight window. Yeah. I mean, if I were flying from, I can think of FAR and Spaceport, New Mexico as two good examples. So like Spaceport, you have Truth or Consequences, the town, which is a badass name for a town. And FAR, you can drift into China Lake, you can drift into Edwards Air Force Base, and like both of those things will cause you capital P problems. So you would want to prevent going that route. How much money do you think you spent on the space shot rocket so far? Not a crazy amount compared to what will be required. I bought 14 phenolic rounds last summer because that was the minimum quantity. I sold 2 of them at a non-cash price, which means I exchanged them for a plasma machine. But each of the 14 were $220 a pop, so it was some amount of money. Each Q motor will be about $2,700, $2,500 in propellant. Call that another $1,000, $1,500 in. Oh, and then the liner. I don't know. Each Q motor is probably like $4,000 all told, but I haven't made any of those yet. Simplex isn't that bad. Simplex uses one of those phenolic liners, existing hardware from Simplex V1. It was about $1,000 per propellant, but I made 2 motors because one of them got messed up, so it was actually $2,000. And then the graphite balloons. I don't know. I mean, I got a bunch of Avas made last summer, and that was like a couple thousand in like a production run. I got some unlocked GPS stuff to verify altitude. That was money. It is expensive, and I'm not complaining because I have a job that weirdly lets me do that. But I will also say I have to think kind of hard about, like, if you're flying like a K motor or like J motor or whatever, that's not to say those motors don't cost anything, but like you can, look at like your monthly budget and be like, oh, I could probably fit like a K motor in here and do like a flight with some tubes from Wildman and some fins and whatever. I could like make this happen in a month or 2 or whatever. And the space shuttle is a lot more like long-term, milestone. We have to spread out the cost. So I don't know how much money I've spent on it so far. I'm kind of trying to not track it too hard, because it is certainly not a cash positive endeavor. Okay, moving on. Since I could not find HTPB during propellant production, I'm thinking of using an epoxy binder. What kind of problems would this cause? Could this make a good HPCB engine this way? I don't think it's a good idea. I think you should try to find HTPB. Epoxy will crack really easily. Will the space shot go Mach 1? It will go more than Mach 1. How's the spin casting liners going? Awesome. The chemicals needed to do it, Gabe says, looked to cost more than the rest of the motor combined. You know what? I can calculate this cost for you right now. So I have a spin cast liner that is HTPB, carbon black, thermocells, Kevlar pulp, IDP, looking at the thing now. Lecithin, CaO5, PDMS, and MDI. So it's all the stuff that you'd use to make a normal rocket motor, but instead of the AP and aluminum, you have Kevlar, carbon, and thermocells. Excuse me. So for an 8-inch motor, I have a spreadsheet that just like does this for me. Let's say ID is 7.5, so we're going 1/4-inch case, and the case desired, or the liner desired thickness is, let's say, 0.25 inch, and the liner length is maybe 60 inches. That's pretty long, but whatever. And we overshoot the mix by 120%. That liner will be $251. Not bad. Pretty good. Like on par or better than the phenolic liners. Ultimately, it's like a good cost-saving thing. It'll be 5 kilograms of liner and $251. Yeah, not bad. Actually, that's better than I thought. So, yep, that's it. All right. It was the FBI that visited Cody. Okay, cool. In general, if one person can develop something by themselves, it's probably not the core critical technical issue worth classifying so hard. Yeah. I also think that, like, you know, the kind of benefit here is I have never worked for Boeing, Northrop, Aerojet, L3, Raytheon. I have never worked for any of these big prime aerospace defense contractors. So, like, and I will say the people who work for those, like, have done a really good job honoring their NDAs. And so I have no proprietary information from these guys that like I'm just learning from stuff I find on the internet and talk to other people about. And I'm not like doing corporate espionage to find out stuff. I'm just like bouncing around in the dark and then I find a solution. In what mitigations? Oh wait, yeah, or precautions would to be taking to ensure fins do not get stuck. Furthermore, pitching a fin. I don't totally know what you mean. I think you're talking about fin deflection and stuff like that. I don't know. Have good connectors. This is not a size of a rocket where we can have like single fault tolerance across the entire vehicle. So 0 fault tolerant connections, but make the connections really good. Any more outtake videos repeating the same line over and over again? I think those are no more. I bought a teleprompter this winter. Really cheap, by the way. You can get one for like $20 on Amazon. It's just a mirror that's at a slant. And then I put a little thing on my phone that scrolls through the text. So I shouldn't have any more of those error videos. Okay. What's your goal this week and how detailed is your planning and time management? Do you follow the 3-2-1 rule? That is a great question. My goal this week is video production. I'm finishing a script today. I wrote most of it yesterday and a little bit of it in a Firestone. No, it was a Pep Boys lobby. I'll tell you what, really quick life hack. If you want to get a bunch of stuff done and you can get it done on a laptop, do it, like, go take your car for an oil change, but ask them to take a long time. Be like, I'm in no rush. And then sit in the lobby with a laptop or on your phone or whatever. I get so much done in auto shop lobbies. It is crazy. I am never more productive than when my car is getting fixed and I have a laptop in like some uncomfortable lobby with some trash reality TV playing, like on the little, TV in the corner. Anyway, my plan for the week is to do a bunch of scripting today, finish that, film tomorrow, and then edit for the rest of the week. And I usually plan like a little bit ahead. I'll put stuff in my calendar. I don't have a proper system, and that's a thing that would be nice to figure out. I've tried a bunch of systems, but the best one that I found so far is just like write stuff on the whiteboard and then start to check it off. I'm sorry, but it will always be the Friends of Amateur Rocketry test site. FARTS. Farts. Yes, no, I love the Friends of Amateur Rocketry test site. Farts are great. Fart. Okay, Could you design your space shot to be fully reusable? No. Same as the other answer from earlier. No, but like I say no 30 times in a row. What I meant by fly a test motor is fly something like Simplex. Yes, sorry, I didn't understand your question earlier, but I do now. I was thinking of flying Simplex for a little bit. I think we're going to fly the meat rocket and see how that goes. If that goes well, my plan is to either make a P motor that is just like a very short version of the Q motor. We'll have a bunch of empty space, and we'll do basically some version of the second stage of the space shot. Or we just go to the full Q and try to fly something really big. I think there's some gap there. But I would love to just go straight to the 8-inch scale instead of trying to do intermediate at 6-inch. We'll see. Pros and cons. I'm launching an all-fiberglass rocket this weekend and hopefully attempting my L1 with it. Other than maybe general advice moving into HPR, you wishing me luck would mean a lot. Thanks. Good luck, Bob the Guy Mark II. Everyone say good luck, Bob, in the chat, please. Let's wish Bob some good luck. I don't know if Bob is actually your name, but yeah, L1 is awesome, man. I remember, like, I was so nervous flying mine. I still have it in the garage, Thrusty McThrustface, but it is... I saw a video of someone flying their L1 on the rocketry subreddit too, like, and they were losing their mind. And I remember exactly what it felt like watching mine go up as high and as fast as it went. And it was super scary because all of my rockets to that point had either been tiny little SDs where they go up kind of high, but then they come back quickly and whatever. Or they were, TVC rockets where they lift off slowly or they just like flop on the ground a bunch. And seeing it go up that high, I was like, oh my God, I'm never getting this back. Anyway, good luck. I'm excited for you. That's awesome. Will NSF stream the space shot? I don't know. Streaming it is so far out. We have to build the thing first, and we have to design the thing first. I'm reading through rocket propulsion elements now. What other essential books would you recommend getting a more detailed understanding of liquid propulsion? A popular one is Huaz and Huang, I think is called. Huzel and Huang, Modern Engineering. What is this title? Modern Engineering for Designing of Liquid Propellant Rocket Engines. This one's, I think, pretty popular. It's kind of expensive depending on where you get it. But it's by Dieter Huzel and David Huang. I have not read it. I have heard good things, though. Is that the same mix Harry Amadeo is working on? Gabe, it's really close. So my mix, I can give you the percentages just off the spreadsheet now. And we're going to do a video on it too in like a few weeks. That'll be part of the Simplex Feast 2 stuff. My stuff is a little different than Harry's. I have 9.85% thermocells, 5% carbon black, 1.4% Kevlar pulp, 62% R45 HTLO, 0.05% lecithin, 0.1% CaO5, 10% IDP. That needs to come down. It's too squishy right now. PDMS is 1 drop per 100 grams, and MDI is 11.6. And also the MDI and HTPV have to, it's like equivalent weight stuff. So those change batch per batch. But it's 83.75% binder, not solids, and then 16.25% solids. We're going to do a whole video on it. The important thing, I think, the thermocells, the Kevlar pulp is like pretty important. Kevlar seems to be sort of a magical ingredient, and we're going to do a whole video on it. We'll talk a lot about it. But it is heavily based on the stuff that Harry did. I just made a bunch of mixtures, tried to see like how well it will flow. Like this stuff does not pour. It basically like it will. It's kind of like pitch. Okay. Excuse me. Sorry. Gotta crack open a Celty boy. Cheers, everyone. All right. I am once again behind. Very cool. Do you think for an APCP binder instead of HTPP, potentially using silicone? Dog, I would not try to do crazy substitutions. Like if you can't get HTPP, that does make sense. Thumbs up. I don't have good advice for you outside of that, and it's not because I don't want to. It's mostly because like motors and making your own propellant is so sensitive to so many things, and like I don't have good or satisfying advice for you, other than like you should try really hard to get components that you know will work. Using HTPP is building on decades, almost a century of solid propellant development, where we've all settled in on like this is a really good binder, and it's good for reasons of cracking and rheology and resistance to G loading and density and like how it burns in a motor, and so it's I don't have a good answer for you, and I'm sorry. What are the approximate launch and landing weights for the space shot? I don't know. Not off the top of my head. It's not designed. I just don't know off the top of my head. I have like a rough open rocket model, and it's like a couple 100 pounds. Okay. Let's see. Hydrolock says, I just skipped backwards a bit. And as I just joined, I hear, I'm not against selling feed pics. I'm not against selling feed pics. I mean, for what it's worth, I'm not against anyone doing whatever they want online, so long as they don't hurt other people. Personally, though, I would be open to selling feed pics if we really needed to raise some funds, but we're not there yet. Let's try not to get there. All right, a lot of good luck, Bobs. I'm not going to make the motor for the meat rocket. That is going to be the CTI N5800. And as Neutronium points out, it is an insane motor. Yep. Joey B, to pronounce Estes right. Estes. I don't know what it is, dog. If Lumineer was supposed to go 10 kilometers, then the 100-kilometer rocket should be the 1,000 kilowatt flashlight. That's a good point. Do you know when you release a new video? Probably early next week is my bet. I am filming for it tomorrow, but it requires, I think, a decent amount of like drawing and animation to explain what I'm talking about. So it will take a couple of days to edit. Will you try an orbital launch in like 5 to 10 years, maybe? Probably not. How do you finance BPS space? That is probably a good question to close it on. So I will tell you how this stuff happens. YouTube ad revenue, and that works when I'm posting YouTube videos. It doesn't work quite as well when I'm not, and it's not that big. It's like not nothing, but it's kind of like grocery money. Sponsorships, which again works when you're posting videos, doesn't when you're not. And the thing that makes it work when I'm not posting videos publicly is Patreon, and that is sort of what these streams are about. So if you aren't aware, for like the last year and a half, every 2 weeks on average, maybe every 3 weeks, I've been posting a 10 to 20 minute video where I sit down with a microphone and a bunch of my footage, and I'm like, what's up, y'all? Thanks so much for joining. I'm going to talk about what I've done in the last 2 weeks. And I publish those videos unlisted for BPS patrons on Patreon, so that if you support the project, you get an intense behind-the-scene look every single 2 weeks at what's actually happening. And so I don't want those videos to go nowhere. That's why we're streaming right now. I like hanging out on live streams and answering questions and talking to people. And I want the stuff that I've done to become a resource for other people. So if people want to look at how I made the igniter for Simplex, now they have this video that's like a little bit more detailed. But beyond that, yeah, the Patreon is how it works. And we're doing chill. We're I'm not going out of business anytime soon, but it is starting to get tighter on the space shot stuff, and I will make it work either way. But if you are interested in supporting, there is a link in the description. I'm pretty sure. I actually don't know that for sure. I believe there is. Eric says it's 100% worth the money, and $5 basically gets you most of the stuff. But yeah, that's it. That's my little pitch. You don't have to support. You will get a lot of the public info on the main channel, and frankly, you will get all the stuff that the patrons get. Just sometimes it's going to be a year or more delayed. So yeah, that is my little pitch for you. If you'd like to support, that's a great way to do it. You also get access to the BPS Discord, and that's my thing. I think that's all I've got for everyone today. Does anyone have any other questions? When in the day is too late to drink coffee? For me, I set that cutoff at about 4 p.m. After 4, drinking caffeine only does this to the anxiety. All right. Let's see. I think that's it. Do I follow CopSub, Copenhagen's Orbitals? Yes, I do. They're really cool. Yeah, well, thanks everyone for joining. I hope you have a lovely Tuesday. I will see you guys again in, I don't know, a week, maybe 2 weeks. We're a little behind. And yeah, okay, one more question here. Do you have plans to upgrade from the 440, or is it still holding up? The 440 is the Tormach PCNC 440 mill that I use, the CNC machine. I actually don't have plans to upgrade. It's about the right size for my garage. It's a little too small to do 8-inch diameter rockets, but I can do them if I'm tricky with it. So we're going to see if we can just stick with it for now. And yeah, that's all I got. And I don't know how to sign off. Does anyone have a good joke? Why do you never see a steam engine sit down? Because it's got a tender behind. All right. Well, thanks everyone for joining. That's a great joke. Everyone say good job, Joe. I'll talk to you all soon. May your skies be blue and your winds be low. Goodbye.